Hey guys, so we are going to solve the LeetCode 19 question, which is remove nth node from the end of the list. So this is a little tricky question because this is not just to delete the second node from the list or third node from the list. Because if we want to delete, let's say, a particular second node from the list, then what we can do is basically define a three-pointer approach, which will be a previous, current, and a temporary to basically hold the next position. What we can do, we don't need temporary, we will just need two-pointer approach. We can just do when our current reaches the actual node value, we can just do previous dot next equal to previous dot next, and this node will automatically be deleted from the linked list. But in this case, we want to delete the nth node from the end of the list. So let's say this is our list, and let's say n equal to 2. Second element from the end of the list. This is the first element, this is the second element, right? So we want to delete this element from the list. So obviously for that, we'll be requiring a pointer which will be actually right over here and not on the node, because we will do, let's say this is the current, we will do current dot next equal to next, and this node will be deleted, right? So for that, our current will be node previous to the node that will actually we want to be deleted, right? So what we can do is, again, here we can do a two-pointer approach. Instead of tracking the node, we can track if our node has, if a second node, say our end node we can call, has reached the end of the list, right? So for this, we can, we have to basically keep a distance of 3 length and a plus 1 between the current and the end node, and that way we can basically delete our element, right? So what we can do is basically, this is a very simple approach, right? And after doing this, current dot next equal to, so current dot next equal to current dot next, this node will be deleted, and we can just return the head to get the updated list, right? But this approach will fail if there is a single node. So there is a single node, our head is basically pointing to that node. It's pointing to null value, right? Let's say we define the end. We will obviously define two loops. First loop will take our end. It will put that end ahead of n plus 1 steps from the current pointer. And then we, in the second loop, basically we can move the end and current simultaneously like a sliding window, right? So let's say we have defined the end initially at the head, right? And our end will obviously jump by one position to reach the null pointer, right? Because in this case, let's say n equal to 1, we will delete this element, right? So let's say n equal to 1, our element e, or sorry, our pointer end will reach the end of the loop, and our current pointer will be right over here. So when we will perform current dot next equal to next, basically c will point to some random next value, which will be null, right? So c next will pointing to that variable. But when we return the head value, the head is now, so it's pointing that element, right? So this node will not be deleted. Okay. So for this exceptional case, and for approach, for taking into account this above case as well, what we can do is, instead we can define a dummy variable, right? So we'll define a dummy variable right over here, which will always point to the head. It will always point to the head. So now when end is over here, we will define the current on the dummy and not on the head. Okay. So when we are doing current next equal to next, so our current pointer, that is dummy pointer, point to next. That means our current will obviously point to this pointer, so this node, this link will be deleted. And now what we can do is basically we can just return the dummy dot next value. So I'll do, so it's slightly confusing, but we can do the same approach in this case as well. So let's say our dummy node is here, right? And the current will be initially pointing. Let's just let's just delete these elements temporarily. Okay, so is the fourth node. Let's say what we'll do initially is initially basically we'll define a dummy node. Let's call it as D. Okay, the pointer D, and current will also initialize at this pointer. Then we keep an end pointer. Now we have to distance the end and the current by n plus 1, right? So we'll move the end pointer by 2 positions because our distance between end and the current is already 1, right? So we have to do n plus 1 distance. That means we have to move the end by 2 positions now, right? We'll do first jump, second jump. So the end will come over here, right? So end will move to this position. Now we want to move the end and the current pointer like a sliding window until it reaches the end of the linked list so that we can delete the n node from the list, right? So our end will jump over here, our current will jump over here. Next, our end will jump over here, right? Our current will jump over here. Now our end will jump over here, our current will jump over here. So that's great. Our current is basically tracking the n minus 1 node so that we can just point that node to the next of next node. So end is this node, that means our loop will get terminated. Now just we want to do is point this node, that is current dot next equal to next of next. So this node will point this, right, next of next. This node will automatically be deleted, and now we will return the dummy dot next, right? And dummy dot next is right now pointing to the head. So that means we are doing it properly. So this logic is working in our case, in this case as well. So let's start the actual coding of this. Okay. So first of all, let's define uh, a dummy variable. Okay, let's node dummy and new. So let's put the value as 0 and let's point the dummy node to head node. Okay. Okay, now let's define a current pointer, right? Which will basically pointing to the dummy node, right? So our current pointer will be pointing to the dummy node. Now let's define an end pointer which will be pointing to the head. Okay, so this node n, right, will be equal to head, right? So now what we have to do is basically we have to space out the head, sorry, the current and the end by n positions, right? So already we have a distance of 1 between it. We have to distance of n. So let's move our n pointer forward by n positions. So we want to obviously do n equal to dot next, but this loop should be running for n times. So let's do n equal to 0 and let's increment the value of n. Right. So after this loop, basically our n pointer will go to this position, right? So now you have to traverse the whole list until the end pointer reaches to the end of the list and the current pointer reaches to this element previous to the nth element that we want to delete, right? So let's put the condition end not equal to null. Let's move the end pointer and the current pointer as well, right? So after this iteration, our current end pointer which reach over here, the end of the list, current pointer will reach over here. Now what we have to do is basically point the current pointer to the next of next, right? So we'll do current dot next equal to current dot next dot next, right? So this node will be deleted. And now after this whole thing is over, we just have to return the head. But for returning the head, we'll do dummy dot next instead of returning the actual head because that will fail. Let's say we return head in this case, right? Return head. So so as you can see, this case is working properly because our dummy node is we have basically pointing properly to the head node. But in this case, it's not working properly. So that's the reason we have to do dummy next over here. Yeah, so it's working properly because dummy, because in this case, exceptional case, the head is always pointing to this node, so a node is not deleted. So that's the reason we have to do dummy node and we have to point that dummy node somewhere else so that when we return dummy node next, it will automatically not track this element and it will delete that element. So this is an exceptional case, right? Let's submit this case and let's see if our code is working properly for all the test cases. So yeah, it's working properly. So yeah, if you talk about space complexity is obviously um, it's not taking any space, so it's now off one, and the time complexity is off n because we're traversing the loop twice, so it's off n. So it's a linear time complexity. So yeah, that's it for the video. Thank you.